In this video, we're going to use the hotspot analysis tool in ArcGIS Pro to identify statistically significant clusters or hotspots using the same database I was using before on conflicts. Before we start, let's briefly clarify that this tool is different from kernel density. The previous tool creates a visual representation of intensity. So it shows where points are concentrated, but doesn't tell us whether those patterns are statistically significant. But in contrast, the hotspot analysis goes a step farther. It uses statistics to determine whether the clustering you see is unlikely to have occurred by random chance, meaning those hot or cold areas are statistically meaningful patterns in your data. This makes it especially useful in conflict analysis where you want to identify locations with significant higher or lower levels of activity, areas that consistently experience violence versus areas that remain relatively calm. So now let's run the tool. First, I will go to the Tools menu and search for the hotspot analysis. Click on the tool to open its settings window. And then for the input feature class, I will select the conflict point dataset. For the input field, I will choose the attribute that I want to analyze. But let me explain this first. This field represents the numerical value that I want the tool to analyze. If every point represents a single event and there's no numeric attribute to analyze, then I can simply select incidence count. But if, for example, I want to analyze the severity of the events at each location, I can treat each point and look for the clusters based on the point value. For example, if I have the number of fatalities, I can use that field. Next, I will give the output feature class a descriptive name. Next, you will see the parameter called conceptualization of spatial relationships. This setting defines how features in your data considers each other as neighbors. In other words, how the tool decides which points influence which others in the statistical analysis. The fixed distance band option is the default and is the most common choice. Before running the tool, open the Environments tab at the bottom of the window and set the output coordinate system to a suitable projected coordinate system, which is critical for the accurate distance measurements. Once all the parameters and environments are set, click Run. The result will be a new feature layer typically symbolized in red to blue colors. Red areas indicate statistically significant hotspots, cluster of high values, and the blue areas show cold spots or clusters of low values. Areas in neutral tones show no significant spatial clustering. In this particular case, using conflict datasets, red hotspots reveal areas where violent events occur more often than expected by chance, while blue cold spots highlight zones with low incidence in terms of fatalities. Here I run the analysis for all years combined, but as you can imagine, if I run it year by year, the results might change. So I will test this by selecting points for the specific year or each one of the years and run the analysis again. I have run the analysis and I have the results for all 3 years. Now, here's something to think about. If the results for 2022, 2023, and 2024 look different, what do you think that means? Now, it could suggest that the intensity and location of conflict are shifting over time, perhaps moving geographically or changing in scale, as you can see here. These differences might reflect changes in political control, military strategies, or social dynamics. So recognizing those spatial and temporal shifts helps us better understand how conflict evolves, not just where it happens. So always consider the temporal scale additionally to the spatial scale when analyzing spatial information.